Welcome back, everybody. So we're going to be doing section 1.5. Now, just to kind of give you a heads up of where we're headed and where we're going, we're going to be doing section 1.5 for 2 days. And then we're going to be doing section 1.5 for 2 days, which means today, Thursday, and then next Tuesday, we'll be doing section 1.5, day 2. Then next week, we will do sections 1.6 and 1.7 the rest of the week. Okay? 1 day for 1.6 and 2 days on 1.7. And then we will do our chapter 1 test after we get done with those 2 sections. Okay? So it's going to be a little bit of time before we have another assessment. But that assessment will be our chapter 1 test. Okay? So we'll have 2 quizzes in this set and then a test. And then right around that time, crazy enough, like this is the end of the 3rd week, crazy enough, it will be almost like time skippable interim. Hi. Anybody know where Hayden sits? Right there. Oh, CC? Yeah. Right by Tommy. Thank you. And let me hand you this. All right. Oh, also, this is not for you people in the class, but anybody watching along at home, if you've been quarantined or anything like that, make sure that you're emailing me to submit your homework. And that goes to, I've been making this announcement all day to my in-person students as well. If you are out, if you get sick for an extended period of time, or you are quarantined for any reason, stay on top of the videos. Stay on top of the videos. Make sure that you're submitting your homeworks too. Okay, you can either send them to me through Canvas. I don't have the assignments open where you can submit something, so you're just going to have to scan it using your phone and then email it to me through Canvas, or Canvas message it to me. You can use your plain email, or you can use your Canvas Messenger, and you can just attach it in there. So those of you watching along at home, hopefully you're watching along at home, you can submit your assignments that way. So try to stay on top of it. All right, so let's talk about section 1.5 and where we're at. Everything that we've done up to this point, every equation that we've solved up to this point has been an equation is equal to a number, right? An expression is equal to a number. An expression is equal to a number. We've had multi-steps in those expressions, but we've had an expression is equal to a number. Now what we're going to get into is an expression equals another expression. Solving equations where I have variables on both sides of my equation and how we solve that, okay? So let's get to it. To solve an equation with variables on both sides, you use inverse operations to collect variable terms. Use inverse operations to collect variable terms. You're going to hear me say that a lot. We want to collect the variable terms to one side, and then we solve. Now, how do we collect variable terms to one side? Well, we want to do this thing called get rid of the little guy. I had another teacher say that to me, or say that this is how they phrased it. That just stuck. I thought it was really interesting. I don't know. It's kind of a little catchy. You just remember it. Get rid of the little guy. Now, what does that mean? Get rid of the little guy. That means that I want to move one of the terms with the variable over to the other side of the equation, and the one that I want to move, the one that's going to be the easiest to move, is the smaller of the 2 variables. So the little one of the 2 variables. So how do I get rid of it? Well, if it's a positive, I just subtract it over to the other side. If it's a minus, I just add it over to the other side. Okay? So let's practice that a little bit. I've got 7n minus 2 is equal to 5n plus 6. 7n minus 2 is equal to 5n plus 6. So here's the process. I see variables on both sides. The first thing that I would like to do, that I actually don't have to do in this equation, is simplify both sides. Can I simplify anything on the left or right side? No. Is there any distributive property to do? Nope. Is there any combining like terms to do separately on either side? No. You may be thinking, well, can't I combine the 7n and the 5n? Yes, but you have to wait to do that until you start to solve. Now, I know some of you guys have been drawing in that dotted line. Awesome. Keep doing that for you guys, because it's going to help you even more now. Because you might think combining like terms and you say, oh, 7n, 5n, 12n, right? No. If I move something across an equal sign, I have to use inverse operations. If I move something across this dotted line, I have to use inverse operations. So which one is the little guy in terms of the 5n and the 7n? Danielle? The 5n. Good. Now, is the 5n positive or negative? So how do I get it over to the other side? Subtract it. So we go underneath it. Okay, that's good. That's not a dot on mine. I thought it was. We subtract the 5n to both sides. And again, it's going to be extremely important that we show all the work and be nice and clean and neat with our steps. We take 7n minus 5n and we get 2n. We bring down the minus 2 that we didn't use. The equal sign stays in the same spot, equals 6. The 5n went away on the right side. And now this becomes an equation that I could have given you yesterday on your quiz, right? This is a simple two-step equation. We add the 2 to both sides. We get 2n is equal to 8. And then we divide by 2. N is equal to 4. Now, can we still check our answers the way that we had been doing? Yeah. It's going to require just a tad bit more work, but we can still check our answers. We just plug 4 in for 7 everywhere where we see it. 4 in for n. 7 times 4 minus 2 is equal to 5 times 4 plus 6. So what did I do there? I took the 4 and I put it in for n every spot where I saw it. Now, this isn't just equal to a number, so I can't just go ahead and plug it in my calculator. I've got to actually do both sides of the equation. 7 times 4 is 28, minus 2 is 26. 5 times 4 is 20, plus 6, 26. That does check out. I know I got the correct answer. I can go back and box n equals 4, because definitively I can say, yes, that is the correct answer, because I checked my work. Questions about the process there? Because in essence, this is the really only new part that we did today, right? That's really the only new thing that we're going to be doing. So let's do another one. I've got 4n minus 2 is equal to 8n plus 6. So somebody tell me, what do I need to do first? Nathan?
You have to subtract the 4 from the 4n and 4 from the 8n.
Okay, 4n moves because it's the little guy, right? 4n and 8n, the little guy is 4n. So, and since it's positive, now remember, I still have some people confused on this. Just because I see a minus sign there, that's attached to the 2, not to the 4n. The 4n is positive, so I have to subtract it over to the other side. I subtract 4n to both sides, and we get negative 2 is equal to 4n plus 6. Negative 2 is equal to 4n plus 6. And again, now this becomes an equation that I could have given you yesterday. We subtract the 6 to both sides. Negative 2 minus 6 is negative 8. We divide by 4 to both sides. Negative 8 divided by 4 is negative 2. Questions there? Now, there's one exception to my rule. There's one exception to my rule. Take a look at this next one. Which one is the, don't start writing yet. Which one is the little guy?
3b.
The 3b, right? The 3b is the little guy. If I were to move the 3b, don't do this. If I were to move the 3b, I would have to subtract it over to the other side. And then I've moved everything away from my right side, which is not horrible, but I've seen in my experience, people make mistakes when they do this. The equal sign goes in weird spots. You can kind of put it all over the place. Go put it where it shouldn't go. So here's what I say to do. If you only have one thing, let me get that to go away. If you only have one thing on the right side, that means, one term with a variable in it on the right side, that means you want to move the other stuff over to it. I want to break my little guy rule and subtract the 4b. Okay? I want to break my little guy rule and subtract the 4b to the right side. Now, would it have worked the other way, sure, we would just have to end up with a 0 in there, and then we could subtract the 2. It would have been all right. But this is the best way to do it, in my opinion. We divide the -1 over to the other side, which is essentially just making the other side negative, and that's my answer. You don't want to leave nothing on one side of the equation. You always want to leave something on one side of the equation. Okay? All right, so let's take a look at the next one. I said at the beginning I wanted to simplify before I start solving. I want to simplify before I start solving. Now, I'm going to add a layer onto the top of this. Can I simplify anything before I start solving? Sid? Mm-hmm. What do I do?
You're going to distribute the 2 and the y from the 2 and the 6.
What's that going to get me?
2y plus 12.
Good. And that's it, really. That's the only new additional thing that we're going to do in this problem. The next step is, again, get rid of the little guy. And I can get rid of the little guy here. I can actually move my smaller variable, my smaller coefficient. So we subtract the 2y to both sides. That's going to give me a 12 is equal to y. And then, boom, there's your answer. And that's it. Questions about that? If you're questioning yourself, throw it back in. 2 times 12 plus 6, is that the same as 3 times 12? 2 times 12 plus 6, that's 2 times 18. 3 times 12 is 36. 2 times 18 is 36. Did I get the correct answer? Yes. I can definitively say yes, 12 is the correct answer. So now what we're adding on top of everything is, okay, simplify, then solve. Simplify, then solve. Let's take a look at this one. Now we've got a problem where we have both sides need to be simplified before we start solving. Both sides need to be simplified before we start solving. Okay. So how do I simplify the left side? Danielle?
You subtract 9 from 15.
Good. I combine like terms. Remember that I'm not going to use inverse operations. I'm only working on one side of the equal sign right now. Don't add 9 to the 15. No. We want to subtract it away. So plus 6. Now, I'm okay with you simplifying the left side and the right side down at the same time. Just keep them separate. How does the right side simplify? Nathan?
2x plus 4.
Right. I distribute to make it 2x plus 4. And now I can get rid of the little guy. What is the little guy in this case? What is the little guy? No? The 2x. So let's subtract it over to the other side. That's going to get me 1x, so just x, plus 6 is equal to 4. Look at that. X is -2. Questions about that? So again, we keep adding layers onto the top of this. Keep adding layers of, okay, how do we simplify? How do we simplify and then solve? How do we simplify and then solve? So let's do that again. Now, you might get overwhelmed if you look at this problem right at the beginning. You might say like, oh man, this seems like a lot. Don't shut down. Just keep doing it step by step. Keep doing it piece by piece. Like for example, on the left side, what can I do? On the left side, Sid?
You can combine 5b and 2b.
Right. I can combine those terms. -5b and 2b. Make -3b. So 3 minus 3b. On the right side, what can I do? Be careful with this. What can I do on the right side? Nathan?
Can you do -2 minus 2 and then distribute that?
I cannot. And that's why I'm saying be careful. You can't, because this is multiplication, you can't subtract before you multiply. You have to do the distributive property first.
Okay.
Sid.
Would you multiply -2 by 1 and then -2?
Yes. So we have -2 sitting there, and then that comes from right there, right? That just carries through. -2 times -2 times 1 is -2. And -2 times -b gets me a positive 2b. Watch out for that. Plus 2b. Negative times a negative is a positive 2b right there. All right. Now we can combine these. It just so happens, it's coincidental that because it was a 1 inside the parentheses, I am going to get my -4, my -4 here. The left side, I don't have anything else to simplify. I keep it the same as it was. The only thing that I changed from step 2 to step 3 is combining the -2's to make -4. Okay, let me ask this question. What is the little guy here? What is the little guy? Because now my next step, now I've gotten constant, variable, constant, variable. What is my little guy in this case? Danielle? It's not 2b? Yeah, because it's a minus, we got to consider it a negative. And what's the smaller value, -3 or +2? The -3. That's tricky here. But it's actually nice and convenient because now I'm going to add that 3b over to the other side, and I'm done with negatives. 3 is equal to -4 plus 5b. And now this is a simple two-step equation. Add the 4 over to the left side. That gives me 7 is equal to 5b. And we divide by 5. Don't be scared of decimals. 1.4 is equal to b. You could have also said 7/5. That is a simplified fraction. That's the same. You could have also said 1 2/5. That would be fine as well. But because I gave it as whole numbers, I can do fraction, mixed number, decimal, doesn't matter. Questions about that? Yes?
You have wait, no, never mind.
You good?
Yeah.
Okay, let's take one more of these. Let's get one more of these. So I got 4 minus 6a plus 4a is equal to -1 minus 5, 187 minus 2a. Again, that seems like a lot of stuff. That could be overwhelming at the beginning. Just take it piece by piece. Figure out a couple things you can do in each step. Like, for example, what's the first thing that I can do on the left side? Just look at the left side. What can I do only on the left side? Danielle?
Add -6a and 4a.
Good. I'm going to combine those two pieces there. 4 minus 2a. And that left side is fully simplified now. On the right side, what do I do on the right side? What do I do on the right side? Somebody that I haven't talked to today. What do I do on the right side? Very good. Yeah, just remember that it's a -5 coming in, because that's the tricky part. Watch out, it's a -5, right? So we bring down our -1, and -5 times 7 is a -35. -5 times -2 is a +10. Watch out for that +10. Make sure you have that written in there. +10, not -10. +10. All right, so we carry through with our 4 minus 2a. Don't change that at all. I'm not going to do anything with that left side because I can still combine like terms on my right side. I haven't done any inverse operations yet. -36 plus 10a is the fully simplified version of my right side. And now I can get rid of the little guy. What's the little guy? What's the little guy? What's that? The -2a. So I'm going to add the 2a over to the other side. So now that gets me a 4 is equal to -36 plus 12a. I add the 36 over to the left side. Simple two-step equation now. 36 plus 4 is 40. And now I divide by 12. I finish it off by dividing by 12. And 40 divided by 12, 3 1/3. I would accept 3.3 repeating. I would accept 3 1/3. I would even accept the fully simplified improper fraction 10/3 as well. But I bet a lot of you would just say negative, or just say positive 3.3. What is that?
See that? What's wrong?
It does.
It looks like a meatball.
Did somebody
It
like
looks like
that?
the German flag.
Can I go down and get it?
No, that's okay.
Or-
Maybe it's from a science class or something like that. It looks like a little parachute.
Pears.
People have been
The janitors are
how
having
they're
fun.
coming for us.
The janitors are having fun.
That's must be that. All right. And you know what? Everybody's having fun because we're doing math in here. They're throwing parachutes out. It's just a crazy day. It's just so much fun. Everybody's having fun today.
I'm not. No, not.
You know what? Let's get this party started now. Let's do some fractions. Woo! Let's do some fractions.
First period was hilarious. It was the best.
All right. Now, don't get me wrong. I could solve this equation just by using the fractions. Subtract the 5/6, multiply by 6 over to the other side, and that would be completely fine. But I want to show you a method that will work even when I cannot use the fractions. Here's what I mean. Take a look at this. I've got x over 6 plus 5/6 is equal to 7/12. The process for, if you have all fractions, to clear out the fractions, I can multiply. If you want to write this in, you can. Multiply by the LCD, the least common denominator. Synonym for least common denominator is least common multiple. Right? Least common denominator or least common multiple. How do you find a least common multiple? Well, you take your denominators, so I've got 6 and then 12, and then write out your multiples. 6 times 1 is 6, 12, 18, 24, 30, 36. Take a look at 12. 12, 24, 36, 48. What's the smallest number? And those will go on, right? What's the smallest number that occurs in those lists? In both those lists? It? 12. And that's my LCD. Now, I bet some of you out there are thinking, I knew that was 12. You didn't need to make that list, Mr. Robert. That's silly. I knew it was 12. Awesome. Then you're going to find these problems even easier. If you didn't instinctually know that it was 12, make your list and take the smallest one of your lists. Now, what do I do with that? Well, I multiply the entire equation by 12. Multiply through your entire equation by 12. Can I do that? Is that okay? Is that mathematically allowed? Well, whatever I do to the left side, I just have to do to the right side. And that's okay. So let's do it. Let's multiply in here. 12 times x is 12x. 12 times 5 is 60. Leave your denominators the same. 12 times 7 is 84. Leave your denominators the same. Now, why did that work? Why is that okay? Hold on a second. Why is that okay? Well, because all I did was just multiply through the entire thing by our LCD. Why is this useful? Well, take a look at what's going to happen. What's 12 divided by 6? What's 60 divided by 6? 10. 84 divided by 12 comes out nice, clean, 7. And look at that. My equation got reduced to a nice, neat, two-step equation. Look at that. That's slick.
Wow. I use that all the time now. That's
Just in my daily life, whenever I need to solve fractions. So now I subtract the 10, and I divide by 2. X is equal to negative 1.5. If you want to say negative 3 over 2, that's fine too. Okay, Sid, what's up?
Like if you wouldn't have said that, I would have tried to make them all like the same denominator. So I would have multiplied x over 6 and then 5 over 6 by 2, so they would all have to be like 2x over 12 and then 10 over 12.
Yes.
That's what you want to
Yes.
do.
But when you do that, watch. When you do that, you get, I'm going to put it parallel to this step, you get 2x over 12 plus 10 over 12 is equal to 7 over 12. Guys, look at this. We did that. Didn't we get 2x plus 10 equals 7? Once you make the denominators all the same, the denominators can go away. Can go bye-bye. Okay? That's what's nice about this. I know. Your mind is blown, isn't it? Let's do another one.
I'm not good at math. This helps so much.
Let's do another one. Can anybody tell me, like, right off the bat, I see my denominators. Now, does 3 have a denominator? No, we can say it's 1, but we don't even need to worry about it. My denominators are 15, 3, and 5. What's my common denominator that I would use here? Nathan? 15. Almost everybody said 15. So my LCD is 15. So let's multiply through by 15. Let's multiply through by 15. Okay, that gives me a 30x over 15. That gives me just a 45. This gets me, now 7 times 15, I don't know that off the top of my head. 105 minus 15 over 5, or sorry, 15x over 5. And now I just simply divide. 30 over 15 is 2. 105 divided by 3, 35. 15 divided by 5 is 3. And now I have an equation just like what we started with today. What's my little guy?
2x.
Oh, be careful.
Oh,
Negative 3x. We add the 3x to both sides. So that gets me a 5x plus 45 is equal to 35. And now I subtract the 45 to both sides. 5x is negative 10. So x is negative 2. And I think that's a lot easier than trying to use any fractions. So if you have all fractions, if you want to remove the fractions, it's called clearing the fractions. If you want to remove all of the fractions, you just multiply through by the common denominator, and that will clear out any fractions in any equations. All right, so we will finish section 1.5 on Monday. We'll do some word problems Tuesday. We'll do some word problems, and then I'll give you a bunch of time to work on your homework in class then too. All right. Shut off the video. Bye, everybody. Watch along at home.